lesson is 2.5, which is solving compound, so compound inequalities. The last couple lessons, you've just been kind of looking at inequalities in general, almost like an equation, only it had an inequality symbol. Well, today we're going to look at compound. Now, I refer back to something that we learned in Chapter 1, so let me just go back for a second. In Chapter 1, we had a problem where it was the area of a triangle formula, something like this. And we had to solve for, let's say, B. We had to solve for this letter. And I went through and I explained to you that if we were to divide off a half, if we were to go like this, we would have A divided by a half, and then these would cancel, and we'd have B and H. And I explained in that video that this is really not good, because what you have is you have a double fraction bar. So you have two division bars, essentially, which makes that, or what we call that, is a compound fraction. And in math class, a compound fraction is really a big no-no. But in today's lesson, you're going to see that in inequalities, it's actually acceptable. So what we're going to be doing today is we're going to be looking at how to put, essentially, two inequalities together. Okay? So we only have two of them, and we need to just look at what they are. So if you look at the first two examples here, notice it says explore. So we're going to give you an example of each one. So let's take number 1. It says a number x is less than 7. So let's just throw on here 7. And it says x is less than 7. So we're going to put an open circle, and we're going to go smaller. So we're looking at 6, 5, 4, 3, 2, 1, and etc. Okay, so that's this part. But it also says x is greater than 3. So if we look at 3, it has to be greater than 3. So if you kind of look at my drawing here, if I asked you what is the solution for this statement, you would tell me anything above 3. So we could go, 3.1, we could go 3.7, we could go 4, we could go 5.8. We can go above 3 all the way to just before 7. Well, if you think about all those numbers, that is a lot of numbers. Think about it. You could go 6.04, 6.73, 6.903. I mean, that's a lot of decimals. So how can you possibly write a solution that covers everything? So what we do is we use this compound. And our first compound is what we call an AND. An AND compound is basically you're saying everything from here and everything to here. So what we're going to do is we're going to put our variable in the middle, and we're going to put our low number on the left and our high number on the right. So see how it kind of matches my graph? And then what we're going to do is we're going to point our symbols to the left. Now I know this sounds strange, but just kind of hang with me for a second. If we always stay in this format, low, high, in the middle, your symbols will point to the left. Because what this is really saying is x is greater than 3. And then if I cover this one, x is less than 7. So this is what an AND compound looks like, where you have it kind of in the middle. Now remember, I told you that we're going to have two types of these. Okay, so let's take a look at the other one. It says a number D is less than -2. So let's put -2 on here. So we would have -1, 0, 1, 2, 3. And you don't have to number the whole number line. It's just kind of for reference, just to kind of give you a visual. So -2, so it's less than -2. So we're going to go less than -2. Or, see the difference there? So the other style is the or style. Or it is greater than or equal to 2. So it can be 2 and bigger. But again, man, look at all these possibilities. It can be like -3, it can be -3.6, it can be -10, it can be 2, it can be 2.1, it can be 3.8, it can be 100. I mean, again, that is quite a bit of numbers. But do you see how I have a gap in the middle? That's kind of a significant thing with ors, is to have this gap in the middle. Where ands, it's kind of more dark and filled in the middle. And so it's really easy to kind of just look at their graphs to tell. Now, when we write our solution for ors, we actually keep the word or right in the middle of our answer. So we do an inequality for this side. So we're going to do x is less than -2, or x is greater than or equal to -2. Do you see how I still have the word or in the middle? So these are your two styles. And the only really thing they're going to do is they're going to maybe throw some more words at you, and they might complicate them a little bit, make them a little larger than this, you know, add a few numbers in here. But for the most part, you have the entire lesson. So why don't you go ahead and pause it if you want, and go ahead and try these other two on your own. Okay, hopefully you tried it. One thing I like to do with these is I like to kind of try to skim to get an idea if it's going to be the and or the or. So it says a number r is no less than -2 and fewer than 4. So I can tell you right now that I don't see the word or in here, so this is probably an and. So I already kind of know what it's going to somewhat look like. I already can tell you my low number and my high number. So I could actually plug those in right now. The only thing I do have to watch for is, will I need to include any bars underneath? So let's go back and reread it. A number r is no less than -2. It says no less than. So what you're telling me is I can be -2, but I can't be smaller. So he says no less than. So I'm going to go ahead and put the bar underneath. And then it also says that it's fewer than 4. So what you're telling me is I cannot be 4. I can be 3.9, but I cannot be 4. So I've got this correct. Now over here on my number line, I don't expect you guys to number all of these, but go ahead and do at least like, so I have -2, -1, 0, 1, 2, 3, 4. Do make sure that you're spacing them out appropriately, but I don't expect you to label every single thing. So we're going to put a filled in circle at -2. We're going to put an open circle at 4. And then because this is the and, it's going to be everything in between. And there would be my answer. Now, by process of elimination, since we only have two choices, this is probably the or, but I can actually see the word right there, so I kind of already know. But it says a number c is more than -4, so let's go ahead and just do that. C is greater than -4, or at most -7. So if you're at most, that means you must be less than or equal to, because you can't be over it. So you're going to be at most -7. Now this is okay. I would not mark you down for this answer, but notice this is the smaller of the two. So if you did want to rewrite it, you could rewrite it like this, but the first one would also be acceptable. Just make sure that when you go to graph this, you do have to put the -7 on the smaller side. You would have to switch these when you graph. So -7, -6, -5, -4, -3. Just kind of putting another couple numbers here, just to kind of give people a visual reference is simply all. So I'm going to do -4 in greater, so it's going to go this way. And don't worry if your circle hits the next one like mine did. I mean, it's just because I was kind of going fast. And then it's at -7, and it's got the bars. So we're going to do dark, and then it's less than. Notice I don't have a large gap in here, but I do have some numbers that I cannot pick. Like I cannot pick -6. I cannot pick -4.3. So notice there's numbers that I cannot pick, but there's a significant amount of numbers I could pick, okay? So that is the wording style. Now, if we choose or go to the next page, notice you'll see 5 problems here. And really the only thing we've done here is just kind of complicated them. So if you notice 5 and 6 are both ors. And then if we kind of draw a line right here, notice 7, 8, and 9 are all ands. They're just a little bigger. So I just wanted you to feel comfortable going through them. And then at the very bottom, they gave us one application problem. So we'll talk about that as well. So on number 5, if you notice how this is an or, really what you're going to do is you're simply just going to act like this is 2 completely separate problems, because if you notice, they are separate. They really don't have anything in common. So we're just going to solve them like we have 2 problems in one. So I'm going to solve for z, and so I'm just moving the 4 over, and so I get -2. And I'm just going to recopy the word or. And then I'm going to divide by -3, and I'm going to get z. Now what do I have to do with that sign? Whenever you divide by a negative, you need to reverse it. And that is my solution. And now I just need to graph it. So I'm going to put -2, 0. So notice again, see how I'm just giving you a few numbers for reference. You don't have to label every single number. And I'm going to go -2 and smaller. And I'm going to go 9 and greater. And notice how I have a gap in the middle. That's how the ors will always look. Okay? So same thing on number 6. Notice we've got this word or. So if we kind of just envision dividing it and like sticking the word or in the middle. So if you want to go ahead and pause it here and give this a try, feel free. So if you paused it, let me just quick go through the answer. So 10 minus 6, and then I'm going to divide off the 2. And then over here, I'm going to subtract 7. Now I'm going to divide by the negative. So really that's a -1, okay? Just remember when you divide by negative, you have to reverse the sign. Now notice how that doesn't change my, that there's a bar underneath. I just flip the sign. And then I'm going to put the word or. And now let's go ahead and count these out. So 2. Again, just kind of giving you a couple numbers for reference. And then 2 is open and it's smaller. And 5 has the bar. So I'm going to fill it in and greater. And there you go. So I like the ors. The only thing that can get complicated is every problem is really 2. So even though it only looked like 2 questions, we just solved 4 different problems. Okay? All right. Now on number 7, I'm going to grab a separate sheet of paper here. On number 7, if you notice, this is the and, but we have another item in the middle. Really, what you're doing is you're actually solving the left side, and then you're solving the right side. Do you see how those are actually 2 separate problems? But watch my very next step. My next step would be to add 3. My next step would be to add 3. Because the middle is the same, you're kind of in a way working inside out. So sometimes what I like to do is remember, my goal is to get this variable along. So what I'm going to do is work middle out. So if I look at this as a -3, I have to do plus, but whatever I do to one side, I have to do to the other. So do you see how I kind of just did it to every piece of this inequality? So I have 4 plus 3. My symbol doesn't change. These canceled. And now I have 7 plus 3. Notice again, do you see how my symbol doesn't change? And look, it is exactly the way I want it to be. So I put my low number. And I put my high number, and I'm just putting a couple other numbers for visual. I'm going to do the open circle at 7, a closed circle at 10. Now remember, this is telling me that x is greater than 7. So x is greater but x has to be less than 10. So it's less than 10. Do you see how it's dark in the middle? So again, compound ands have this dark overlap in the middle when ors have this gap in the middle. So it's pretty easy to tell the difference between the two just by looking at their pictures. So if you want to try 8 and 9, that's totally up to you. They've got a couple little twists, but nothing I don't think you can handle. So if you'd like to pause it here, go ahead. All right, number 8. I have to start by doing the opposite. So because this is multiplication, I'm going to divide by -5. So that's 15 divided by -5. But what I have to remember is when I divide by a negative, I have to reverse my sign. Now notice it just flips the greater than less than. The bar underneath doesn't change. And over here, because I'm dividing by a negative, I flip my sign and I get a 2. So there we go. Let's put that on our graph. And I'm going to do filled in at -3, filled in at 2, and everything in the middle. So I can pick anything within this range, but I cannot pick a number over here. If I pick a number over here, like let's say I were to pick the number 8. If I were to plug 8 back in here, so if I were to go 15 is greater than or equal to -5 times 8, which is greater than or equal to -10, notice this would be -40, correct? Sorry, I was losing my train of thought. Notice it would be true for this. This one would be true, but it would fail this side. So we want to pick numbers that work for both. Okay, so you want numbers that work for both because this is an and. Does that kind of make sense? So that's what you got to worry about with ands. Okay. If you haven't tried 9 or if you're a little unsure, you do know, remember, the distributive property. So you just have to distribute this 1/3 before you can do anything. There is one other way, but this is probably the easiest way. So let's just go ahead and do it this way. So we would go 2x plus 8, like that. Okay? So now, just like normal, if I were to give you this problem, the very first step you'd tell me to do is subtract 8. So you're going to move the 8 first. You just have to do it to all the sides. So this becomes -16, and then this cancels, and that's a 4. And then just like normal, I need to get rid of this 2, so I'm going to divide. So I have -8, and notice I'm not changing my symbols at all because I divided by a positive. So this cancels, and I get a 2. So that looked kind of complicated and messy, but it really wasn't that bad. And notice it didn't really require that much work. So I'm going to go filled in, and everything in between. And there's my and. Okay? All right. Last but not least is the story problem. The story problem in this is really just to kind of give you an idea of where, this might be used, okay? Really, for the most part, you need to really focus on 1 through 9, okay? So I just want to give you an application part here. So number 10, it says, a bike shop rents bikes with heights ranging from 18 to 26 inches. The shop says the height of the bike should be about 0.6 times a cyclist's leg length. Write and solve a compound inequality that represents the leg lengths of cyclists the shop does not provide bikes for. Let's not worry about this word just now. Let's worry about what they do. So I'm going to go over here and I'm going to say, what do they do, provide, or sell? Okay. I know they sell from 18 inches to 26 inches. But what you're supposed to do is go 0.6 times your leg length. So I'm going to just put 0.6 times x. That's my leg length, okay? So once I know my leg length, I would take my calculator and I would times it by 0.6. So let's say my leg length is, I don't know, 30 inches. Let's just say 30 inches. My leg is 30 inches. Oh, yes, they have a bike for me. Let's say my leg length is 37 inches. Yep, they've got one for me, okay? So what they're telling me is that they're going to sell above the 618. They're selling greater than this, but this and smaller. So do you see how I've done my compound for what they sell? Now, I do need to solve this for x. So I'm going to divide off the 0.6. So I'm just going to use my calculator here because I don't know those off the top of my head. So just notice how I'm just typing them in my calculator. So I've got 30 and I've got 43.3. So if my leg length is between 30 and 43 1/3 inches, they got a bike for me. This is they got my bike. But up here it says, what do they not provide for? So let's take a look at this. If you're above 30, you're good. So what happens if you're below 30? No bike for you. So they do not provide for people if you are below 30 inches, if your leg length. Now, 29.9, no go. But if you're 30, you're good. So see how I switched the bar. Then we're going to do the opposite. So instead of an and, we're going to make this an or. So if you're below 30, if you're on this side, no bike. If you're on this side, you're too tall. No bike. So now notice what we have here. See how it says x is less than? So we just switch it. So we're going to say x is greater than 43.3. These are the people that it does not provide for. Again, that is just a little application just to kind of show you where a compound inequality might be used in real life. But that concludes lesson 2.5.